saw with the cross ratio. So in previous classes, we saw how we could take the real measurements from A, B, C, and D, and then use those to solve for a missing measurement. So we have 1.2 and we have 1.1, and then for that last piece we can solve for that x. Now I've expanded this to include more letters. So the process that we're going to be using is we'll use the cross ratio to solve for that C prime to D prime. So that'll be the x that we solve for. And then what we have is a new project. So let's say that C prime to D prime is equal to 0.87. Then we'll reset our cross ratio and use B, C, D, and E to solve for the next missing dimension in our drawing. And then we'll move that over again, do the cross ratio with C, D, E, F, and then D, E, F, G. So each time we're using the previous two measurements in our drawing, and we're able to figure out the next drawing in that chain. As you're going through this process and watching me make this drawing, I want you to think about what you might want to be drawing for your own project. There's going to be a couple of limitations on it, the most important of which is that your object that you're going to be drawing, whether it's as tall as a building or as small as something that can fit in your hand, it needs to have 6 pieces of interest along some axis. So something like a cardboard box that's just plain with no writing on it is not going to have enough interesting things to draw in perspective. But something like a car engine is going to have a lot of interesting spots along the side of that. Or the face of a building is going to have the start of a doorway, the end of the doorway where the doorknob is, right, where the wall starts and ends. Maybe there's an archway above there that hangs over. So as you look along one of the axes of that object, so let's say along the length of an object, you want to be able to identify at least 6 interesting pieces along there. The tool that I've built for you is going to allow you to use as many measurements as you want, and you'll be able to make a perspective drawing using that. The most important thing when you're choosing your object is not whether it meets the qualifications of the number of points of interest, or if it's something that you think is related to architecture or whatever you're majoring in. That is less important to me than whether or not you think the object is interesting. So this is an object that you're going to be spending a lot of time studying and finding the details of and measuring and trying to depict for a piece that you're going to be putting in a portfolio. So again, please choose something that is interesting to you. I know the temptation is going to be to pick something off of your desk and convince yourself that you will have fun drawing that object. But I guarantee you that drawing that stapler is not going to be as fun as taking the time to find a building that you find interesting, or maybe even taking a picture of something outside, or finding an image of something that you like online that has some dimensions to it. Either way, pick something that's interesting to you and it'll motivate you to make a better portfolio piece. In the next video, I'm going to go over how to take some measurements of an example piece. I purposefully chose something that's a little boring, but it demonstrates the techniques that I want to teach you for this really well. So that'll be the next part of the video. And then once that's done, I'll show you how to use the Excel tool that I was using. And then lastly, I'll show off the finished piece and give some tips for what I want to see with the drawing. So what I have here is a piece that I got off of McMaster-Carr's website. So this is just a CAD file that I printed out as a PDF. They have this for a lot of the parts on their website, but for this one I just chose a rack with 3 hooks on here. Now, this one came with some dimensions on here, but for our drawing, I want to have as much detail as possible, and that means including, kind of dimensions for where this hook shows up and maybe even where this hole is lined up here. So what that means for my drawing is that I want to ignore these dimensions here, all right, that were provided, and I'm going to just use the dimensions as they appear on this file in inches on here. So clearly this is not going to be 12 inches. It's actually 12 inches in real life, but whatever scale we end up using, that's going to be the scale that our whole drawing is going to follow, and that's okay. All right, so just some points of interest here. I'm going to try and draw some straight lines here. Along this axis, I'm interested in, let's just say for the sake of argument, these dimensions here. So here I've got my points of interest, and I'm just going to label them A, B, C, D, E, F, G, H. So I'll start off by figuring out this distance here, AB. And that looks to be 1, 2, 3 eighths of an inch. I'm going to suggest getting these as precise as you can. So if you have a ruler that's either working in millimeters or in 30 seconds of an inch, that's going to be best. My measurement BC from here to here, that looks to be 1/16 short of 1/2. So that's not going to be 8/16, that'll be 7/16 of an inch. From C to D, that's going to be equal to, and that looks like 1/8 short of 2 inches, and that'll be 1 7/8 of an inch. Yeah, we can proceed from there. Looks like DE is going to be 1, 2, 3 eighths plus a 16th, so call that 7/16. EF is 3/4, right on the dot. FG is going to be 1, 2, 3 eighths plus a 32nd. So I'm actually just going to write it just like I announced it there. So that's 3 eighths plus 1/32. I'll do the math to figure out what exactly that is when I get to the end. And looks like this last measurement from G to H is going to be 3 eighths right on the top. Okay. Now for each of these, I'm going to convert them to a decimal amount on here. So if you're measuring this in millimeters, again, you won't have to do this step, but so much of architecture ends up being in these imperial units. So This is a good opportunity to get some practice in with doing these accurately. So I'm going to take these to my calculator, and I'll be back with all of the measurements that way. So what I have here is the cross ratio calculator. This is a spreadsheet that I built in Excel that's going to do all of the work for finding those drawing dimensions for you. There's still a little bit that you need to do on your own, so it won't do everything, but it will make a lot of the work easier. So if you take a look, just as an example, here's one of the cells that I calculated, and this is the formula up top here, you can see. So that's going to make things easier for you. If you've never used Excel before, you can use the arrow keys to click on these different cells. So these little boxes are cells, and you can type in numbers to fit into those boxes. The way that I've designed this is that you should only have to fill in the orange boxes. So you shouldn't put anything in these blue boxes. The orange boxes are what you need to fill in. The top row here is the real dimensions. So the real dimensions are going to be from your from our CAD file. And those will be the distance between each of the points of interest. So I could call this 20 and 20, and let's say that my dimensions look something like this. If I only have these 1, 2, 3, 4, 5, 6, I can always just delete everything there. So I just highlight by clicking and dragging, and then hitting the delete key on there. So however many dimensions you have, you should fill those in across the top there, and then click and drag and delete anything else. If you have more dimensions than what I have provided numbers for on here, you will have to extend this pattern here. So what that's going to look like is, let's say you have 11, 15, 15, 15, 18, 21. Excel will automatically calculate formulas for each of these cells. If you just highlight this last cell here, and then you're going to want to put your cursor on the bottom right corner of this cell. So the bottom right corner of that cell has a little square on it, and it'll change the color of your icon to this filled in black plus sign. And so once you do that on this last cell, you can click and drag and extend it out to however far you need. So again, you can delete whatever you're not using, or if you need more, you can always take this bottom right corner of the cell once you've clicked on it, so you can see it's highlighted, and then I'll click and drag. If you're not able to do the things that I'm doing right now, it's possible that you didn't download the Excel file and open it in Excel, so you won't be able to manipulate this from Canvas. You'll need to actually download the file, the XLS file, and open that up in Excel to be able to change the numbers on here. Okay, so let's say that these are my real dimensions on here, and these are my drawing dimensions. We need to pick the first two numbers, right? So remember, it's not going to be able to solve for all three dimensions in our drawing. That's something that we'll need to do based on the composition of our piece. So but you'll see a little later in the video how we can choose these numbers, but again, these are orange boxes that we can fill in. So let's say this first one should be 100, and this next one will be 87. The way that I've set this up is that you can pick the first number, so 100, let's say millimeters, and this upper limit will tell you what this next number should be. If I write the upper limit in here, that's going to cause the rest of these numbers to be a little wonky, and it might give you some weird results that you're not going to find very helpful. So my suggestion would be to pick something like 100 for this one, or just pick a number that makes sense based on your drawing. And then for the second cell, pick something that's a little bit under that upper limit, so something like 80. That way, once you get to your next dimensions over here, you'll get some reasonable numbers. And this calculated value down here will tell you what the total length of your drawing is going to be. So along that axis, it looks like we've got a total of 281 millimeters. So just about 28 centimeters, so just under a foot. So maybe that makes sense for a composition. If we want to change that, we can also make that a little lower, scale it down, or potentially give ourselves a number that's a little bit closer to what we were looking for. But either way, these orange values, once they're filled in, are going to be able to calculate the rest of the blue values for you. Part of your project is going to be submitting the Excel file with all of these numbers filled in, just so that I can take a look and see that you've made some real measurements on there and how those pan out in your drawing. Now that I've got all my dimensions in this direction, I also want to measure some spots of interest along this vertical axis here. So I'm just going to have this piece right here. Actually, I'll look at where I'm going to make one more of these. I'll draw another line of interest here. And those look to be about 1/8 each. 1/8, 1/8. Okay, so I'm just going to list these heights just from top to bottom like they are here. 1/8, 3/8, 3/8, 1/8, 1/8. Okay, so each of those heights are going to hopefully add up to what we see as our total height here. And if I measure this here, it looks like the total height is going to be 1 inch and 1/8. You could also measure it from over here, and it turns out that that total, either way you add it up, is going to be 1 and 1/8 inch. So adding it up here will give you 1 and 1/8. I'll call that 1.125 inches, and you can confirm that you've made all your measurements correctly by just checking, yes, in fact, this is 1 and 1/8 inch. Okay. Now that we've got all of our real dimensions into our Excel spreadsheet, we can start actually making our drawing. Before we use those values that the cross ratio calculator spreadsheet is determining, an important first step is going to be to sketch out our composition for what I want our drawing to look like. So I'm going to be using this as a reference. So I want it to look sort of like this, but maybe a little bit more at an angle. And then, of course, we're making a perspective drawing, so this orthographic drawing is going to be foreshortened on there. So, but that's the basic layout of what I want, and I want it to be a little bit more at an angle. So what I'm going to do is just kind of draw sort of where I want the upright part of that bracket to be. So I kind of want to have it sit over here. And again, this doesn't have to be perfect, right? But I think that's a nice angle of it. It's got enough foreshortening on it. And hopefully you can see that in the video. Yeah, it looks like that's showing up all right. Maybe draw it a little darker on here. You can do this with your nice light sketching pencil. But yeah, that's some nice foreshortening. I like the composition of that, and maybe I can have some technical details of it, like a little title or something here. Anyway, so these 2 points should intersect at some vanishing point. So go ahead and draw the top and the bottom line intersecting at some vanishing point here. We'll call that our vanishing point. And then you want to think about your first 2 dimensions in your drawing. Now, that's going to be these 2 dimensions from here to here and from here to here. You'll notice in the Excel spreadsheet that there's 2 orange spots where you can put some of your own dimensions. So that's something we'll need to figure out. What 2 dimensions make sense for those first 2 dimensions in our drawing, and then the cross ratio calculator will figure out what the rest of them should be. Because Excel is working in decimal places, but I think it's going to be a lot easier to, now that we're in our drawing, to work in millimeters and centimeters. So that's what I'm going to be using. For this, I'm just going to be counting the number of millimeters that I'm using, because it's going to be pretty difficult to use inches and fractions and just having to be converting all the time on there. So whatever nice scale that works well with decimals. I know that a lot of you have rulers that might have tenths of inches, where you can use that nice decimal marker on there. But I'm going to be using millimeters for this. That's going to be my units. And it doesn't matter what units you're using. The cross ratio calculator will just spit out whatever the outcome is in those dimensions. Okay, so because I've got one piece that's this length and then one piece that's a little bit longer than that, I'm thinking that maybe I start off by having this be about 4 centimeters. All right, so let's say my first dimension, I want that to be 4 centimeters. And then the next dimension, I want that to be, I'll just try 15 millimeters. All right, so those 2 dimensions here, just as a first guess, would be 40 and 15. If I plug those into the calculator, I'll see that with those dimensions, the next few dimensions get really small really quickly. And also, if you look down at the calculated total length of the drawing, the total length of that drawing is going to be fairly short. you can see the total length calculated in the drawing is going to be just 70 millimeters, so 69.57. And that's only going to be just about 7 centimeters. And that's not going to work for us, right? We can see that we want the whole length of the drawing to end up being a little bit closer to something like 18 centimeters, so 180 millimeters. So rather than use 40 and 15, I'm going to keep this 40 the same, but I'm going to start experimenting with some numbers here. So maybe in the next iteration, I see what that looks like if this first dimension's 40 and the next dimension's 40. And that's okay because that's an okay assumption to make, because if I look at my original drawing here, this is 3/8 of an inch, and then this is a little bit more than 3/8 of an inch. So when that gets foreshortened, it's not crazy that this piece that's closer is going to be the same distance in our drawing as this piece here. I do have a upper limit that'll kind of tell you what number you shouldn't go past for this second dimension here. So that's automatically calculated. But let's see what 40 and 40 does. So you can see 40 and 40 is going to give us a total length of 138 millimeters. So that's looking a little bit closer to what our composition is. But let's just scale everything up so that we get something that's a little bit closer to this 18.5 centimeters is what we're looking for. Okay, so it looks like if I tried 50 and 50 for my first two dimensions, I tried 55 and 55, and then scaled it back to, it looks like 54 and 54 gave me just about the 18.5 total centimeters that I was looking for. So that gave me 186. So maybe I'll try 53 and 53. No, I think I like 54 and 54 best. Okay, so now we can use our sketch as a rough guide, but now that we have some straight lines to work with, I'm going to erase most of my sketch on here. Again, if I'm drawing things pretty dark on here so that they show up on camera, but this would be a good use of your lighter pencils on here to draw this sketch. And then now that we've got something a little more substantial, we can start to use some stronger lines here. This sketching step is important, even though the cross ratio calculator is going to calculate everything for us. It's important to have a nice composition. You can get something that's really extremely foreshortened if you don't think about this. Now, I've drawn my lines coming off of that vanishing point. And I think those are looking pretty good. For a 1-point perspective drawing, which is what we're working with, at least for the time being, all of the vertical lines are going to stay vertical. So you can use some of your drafting tools. I'm just using my 30, 60, 90 triangle. Kind of get that all set up here. Actually, I'm going to go ahead and measure just along this bottom piece here. I want that length to be just exactly what it is in the total length of the drawing. So that's going to be 187, just about. So 18 on that line again, 18.7 looks like right about there. Okay. So that's looking pretty good. I'm going to get rid of some of my sketch lines here. For the next step, I'm going to start taking my dimensions from the Excel spreadsheet and just starting to mark them along this bottom line here. So these are all measured in millimeters. Looks like we've got 54 for that first dimension. 54. And then 64, which might be alarming that we have something larger, but remember these points aren't evenly spaced. We've got this nice long extension on here for that next one. So that makes sense that that would appear a little bit longer in our drawing, but still being foreshortened though. Okay, so that's going to be, looks like 64.5. I don't know that we'll have enough precision to actually put that half in there, but here's 64. And then we've got 5 and a 5, or sorry, a 5, 6, and 1. So that's 5, 6, and 1. So again, some pretty extreme foreshortening happening over here. If you decide that you like the look of that, I think it's good to, in a perspective drawing, just really show off that you're doing a perspective drawing. That makes it feel nice and stylistic. If you want something that's a little bit closer to the orthographic drawing that doesn't have any perspective shift on there, what you can do is use that upper limit calculation. So still trying to get that total length of the drawing that you have here. So that 18.5 inches. So instead of 54 and 54, maybe try using something more like 50 and 55. So if I make that first dimension 50, I can see my upper limit is going to be 58. And I can use 55. And that'll give me a little bit more of a still right around 18.5 centimeters in total. But that's going to give me a little bit more room over here in the back here. So we'll have 2 millimeters rather than what we're working with. Okay. Now for the next step, for this next step here, I'm just going to start to, got some cat hair on there. For this next step, I'm going to just draw the rest of my vertical lines at each of the spots that I've set up for myself here. So that's going to be again, these are sketch lines, right? They're going to kind of produce this grid. Oh yeah, that's some nice foreshortening on there. That's looking great. Okay, in terms of the dimensions in this direction, so that kind of takes care of the some of the vertical lines on here. I do want to draw some of these hooks sort of sticking out on here. And again, in a 1-point perspective, those are just going to be purely horizontal lines on here. But in order to figure out how much they should stick out, the idea that we're going to use here is that if this dimension here, from here to here, is the total height of our object, then it should stick out proportionally that same amount over here. So we'll kind of use that as a guide. Even though the hook is not sticking out at that point, that's actually the first one is sticking out over here. We're still going to use that total height of the object, and then we'll have it stick out over here. So if I look at the total height of this object, I can measure that out. And again, I'm going to start working in millimeters again. So if I measure my total height, that is going to be 13.5 centimeters. So I'll kind of mark that over here. So looking back at my drawing here, I've got all of these heights, right, that all add up to 1.125 inches. And then in my drawing, this total height is going to be 135 millimeters. In order to figure out how these heights, again, there's no foreshortening happening. We're just going to be making a set of ratios here. So what we want to do is figure out our conversion factor. So I'm going to make a second column here for my heights. The total in my drawing, so we have kind of these real dimensions and the drawing dimensions. My total is that 135 millimeters. And again, it's totally okay to have a mix of units here, right? As long as we're staying consistent, everything in our real dimensions. These are all inches, and everything over here is going to be in millimeters. So between here and here, we have some kind of conversion factor. So to get from 1.125 to 135, we are looking at a conversion factor of 135 divided by 1.125. And so it looks like, again, that 135 divided by 1.125 is going to give us 120. So to get from here to here, we multiply by 120, right? 1.125 times 120 is going to give us 135. And then so for each of these, we're going to multiply by 120. So 0.125 times 120 is going to give us 15. Same thing for this next one. That's also 15 millimeters. This will be 15 millimeters as well. This will be 3 times that, so we can either multiply our 3/8 by 3, or we could say 0.375 times 120. That'll give us 45. What? My cat wants to join the video. Come here. Ah. I'll be sitting on my lap. Okay, so now we have all of our heights converted, and our last dimension is going to be this length. So we're interested in how far this comes out. This part of the bracket's not going to be visible, so I'm just interested in this dimension here, and that ends up being perfect, exactly 1 inch. All right, actually, let me call that 30 seconds, just for the sake of argument here. So 30 seconds is going to be 1.03125 decimal form. Okay, all right, so that distance from here to here, 1.03125. Okay. In order to have this scaled properly, again, in our drawing, this height should be 135, and so our length can be that equivalent on there. We can think of this as being, so this is kind of the other way to think about what I did with the heights here. If this is 135, and we're trying to figure out what this measurement is, so how far it sticks out, I'll call that Z. Whatever that ratio between 135 and Z should be the same between this ratio of the height and this length in the drawing. So this is 1 1/8, 1.125, and this sticking out here is 1.03125. So the idea is whatever the ratio between this height and this sticking out should be the same as this ratio between this height and this sticking out. You can set up an equation like this. All right, you can think of these if you're familiar with the concept of similar triangles. These are similar triangles. So this ratio is the same as this ratio. When we cross multiply, we get that Z is going to be equal to 135 times 1.03125 divided by 1.125, which is going to give us the following. So looks like we have 123.75. Now that's going to tell us how far these stick out. So now that I've got my other dimensions figured out, I've got all these intermediate measurements in here and how far they're sticking out. I'll show you how to use those in the drawing. Okay, so we have 135 millimeters up top here. I'm going to get rid of some old markings. Another version of this on here. So vertically, I figured out that I've got 15, 45, 45, 15, and 15 along here. So I'm going to start marking those. We'll start from the bottom here. So I've got a 15 centimeters. My camera setup is making it so I can't really draw this on here. So let's see, we've got 15 and another 15. And then 45. So 1, 2, 3, 4.5. Another 1, 2, 3, 4.5. And if we did everything right, we should have just 15 millimeters in between here and here for that last measurement. And in fact, we do. So again, lots of little points along here where you can check, see if you've done your work properly. Now I can draw some guidelines along here. Again, everything should line up with this vanishing point here. So try to aim right for the center of that vanishing point. I'm actually noticing that my pencil is not quite sharp, so if you're using non-mechanical pencil, get that nice sharp point on there. Again, I think when people usually make perspective drawings, they're doing a lot of eyeballing to get things to look like they want, but kind of taking this analytical approach to things, I think really gives you a nice guideline. And then once we finish up with our kind of depth dimension here, or this third dimension on here, we're going to get a nice grid that we can, sort of draw a little more creatively along here. So let's see. For our last dimension, moving in this direction, so we've got our height set up here, and for the depth, we figured out that this was 123.75 in order to maintain that ratio between these. So 123.75, I'll call that 124, just because I don't know if I can split a millimeter into 4 pieces accurately. In your setup, you've got your nice desk that you can tape your drawing down when you're working on this and use all the tools that came in that kit there, but you really don't need anything more than what I've got here, just a ruler, a piece of paper, and maybe some kind of straight edge is nice. Okay, so I'm going to line this up with my spot here, and that dimension, again, is 123.75. So that's going to be 12.7. So what we say, 124. Be right about there. So I'll go ahead and draw my line connecting these two spots here. And then if you look at the drawing itself, the only spots where that depth becomes important is at C, D, and F. Those are the spots where the hooks are actually sticking out in here. So if I look at C, D, and F, in order to figure out, I've already drawn some horizontal lines here, but this setup, draw a thicker line here. Right up at this point here, I'm going to connect that with my same vanishing point. I can already see, just because I'm being a little bit inaccurate here, it seems like my vanishing points are really getting at this point here instead, so I got it. I'm just going to move that over. I've got some nice natural light here, but that's making it a little bit hard to see what I'm doing with these opaque rulers, or sorry, these transparent rulers, I mean. But at those points where I have a hook at C, D, and F, we can see they're going to be sticking out right along those points there. So overall, we've got a nice grid to work with. We can see where those hooks are going to be sticking out. And now comes the time to take this grid. This is your setup, right? I'm just going to mark a couple more interesting spots along here, right? So this is 135, this is 123.75, and then I've got my, of course, calculations along this axis. Now it's time to look at our reference and kind of see where some of these interesting spots are going to happen. So this is the point where you're going to be using a little more creativity, right? We have that base grid to work with, but I kind of wanted to keep it relatively short with the amount of points that I was looking at on here. But in your actual project, you might want to maybe add a couple more points of interest if you've got something more interesting going on here. But I'm going to use some eyeballing here. So let's see, I've got B, it kind of starts this mounting bracket here, and G going past F here. So if G is going past F, but not quite making it to E, maybe it looks something like that. This one, again, this starts at B. That other mounting bracket starts at B and goes past C. Looks to be closer to C than it is D when that ending point happens there. So I'm going to look for this point again halfway between here. And it looks like it starts to curve. Right around there. And let's see, just a little bit after B, we're going to have a circle here again. I just kind of picked, I thought, a reasonable amount, 5 dimensions on here, but you could really be making a nice reference grid for yourself here. Okay, so before B and a little bit after, or sorry, between B, closer to B here, we also have another setup over here. Was really foreshortened. I think that's going to have a nice stylistic look on there. In terms of the hooks on here, I think paying attention to some kind of key points in the reference here. Start with this one at B here. So this measurement here, this is kind of the, I'm going to lay out the lines on here that are actually in that shape. Again, I'm using a pretty sloppy style for this. If you want to make yours nice and clean and just have, just kind of use, thicker pencil lines, that's also great. Had a lot of people do some shading in between there. But it looks like for this one, so going from A to B, it kind of curves down. So we have a little bit of a bevel here. Curves down to B. And curves out to C. And our hook looks like that. In between, again, this would be if I was doing something for my own project and not a tutorial, I might actually include this dimension here and some of these other points of interest along here. But right now I can just kind of see it's a little bit, looks like about halfway between B and C. So we'll put that point there. Yeah, it looks like it curves. A nice bevel on the way in and a bevel on the way out. In terms of the hook that's coming out here, looks like from the drawing comes straight out. And then again, straight out from this spot here. But then it's got a little bit of a part that actually hooks into it. So looks like it comes down at a slight angle. Shoot. Coming up looking like that. And that line continues all the way out to D, where it curves down. Again, back to this line. Oh no, curves a little bit past D. So again, there's that halfway point between D and E. And at E itself. Curves this way. So we have our second hook. A neat little trick that we can do now that I've drawn this one, if I want all of them to line up properly, so if I want to see where this little crook is on there, I can set up that same scale, going to my vanishing point. Some of these lines are going to be hidden in the actual drawing here. And for this last one, we can just sort of give the idea of a hook, since we're working so far away from the camera, right? This is your spot where you're, just drawing Bob Ross style trees in the background instead of drawing each individual leaf. You're just drawing the idea of trees back here. So let's see, this one is hooking around in the same direction as D. Okay. Once I've got this a little bit more cleaned up, and maybe I add a little more details and embellishments, I think this kind of sets the standard for what I think a good perspective drawing is going to look like. My hope is that you have something that's a little bit more interesting than a this looks like a rack for hanging kitchen supplies on here. But kind of taking this for your project, what I'd like you to do is take a picture of your setup in this state. And I also want you to take a picture once you get your grid with some of these dimensions on here. So I'll have a complete list of the things that I want you to send for your project on here. But once you have the sort of technical portion of it, right, like that grid, before I started drawing these lines on here, once you have the grid, that kind of concludes the technical portion of it. And then you can just start to, I don't know, give your artistic interpretation of it. So we'll start going a little crazy with it. Now that I can be a little bit more confident with what it actually looks like. Again, you don't have to do this, right? I'm happy to have you take a picture of this and work with it digitally. You can, paint over this. Oh, that's kind of a bevel to it up there too. But once you're working with a more interesting object than this food rack here, right? This could be an object that you have a digital picture of, right? Something, if you're doing industrial design, maybe you can look at some designed object that you really like there. If you're doing architecture, you can do, right, the face of a house on there, or even an entire street corner that you find interesting. But in any event, the important thing is that you choose an object that you are interested in. All right. So I am going to be a little bit disappointed if you just go to your desk and you pick the first thing that your eye catches on your desk. I understand that the temptation is there to do that. But again, this is going to be a portfolio piece, right? Like, you want to have something that means something to you and indicates to the people that are looking at your portfolio what you're all about, right? So, anyway, that concludes this tutorial on how to do this, and we'll get some more practice with this drawing next class. All right, see you then. I wanted to end this video with just a couple tips on how to make your drawing really interesting. So first, when you're picking your object, again, on the one end of the spectrum, you have an object that's entirely organic. So picture maybe a house plant that's made of vines, or your pet cat, right? So those are, one, going to be very difficult to measure accurately, and two, once you've got your sort of grid layout, because they're made up entirely of curves that are not circular, that's going to be very difficult to freehand that once you've set up your grid like we did. On the other end of the spectrum, you have a box with nothing on it. So picture a cardboard box. That is not going to have enough interest for you, right? So I trust that you are able to, without opening that Excel sheet, draw a cardboard box in perspective. But what I want to see is something that uses the techniques that we saw today. If you want to get inspired, I would maybe take a visit to the Art and Architecture Library. They have lots of magazines with sort of a modern architectural features and lots of industrial design trends. You can also take a look at any of the books there. Again, you don't have to do anything other than look at the pictures on there, right? And find something that's interesting to you. You can also take out some of the larger elevation drawings. So they have blueprints. If you talk to the people at the desk, they'll be happy to point you to some of the blueprints and help you get them out and take some pictures of them. That would be a really great way to get some very accurate measurements off of something. And when you post that portfolio piece, if you have the blueprints and your perspective drawing next to it, very, very impressive to me and anybody viewing that portfolio. That's going to look really nice and professional. I'll say one more time, just please avoid taking the first thing that you find off of your desk. You're going to be spending quite a bit of time drawing this. And if you have, just this clip, right, or a television remote at the end of it, but that's going to be a very boring process for you, right? And when you put that in your portfolio, I don't think that anybody's going to look twice at that, right? When they see just some random object that feels very Art 101 without being too condescending. So, yeah, find something that you're passionate about. That'll make, uh, creating this drawing and kind of getting into the details easier, and you'll be more motivated when you do that. But I showed you a technique to make a 1 point perspective drawing. If you really want to go the extra mile and make a 2 point perspective or a 3 point perspective, you can start with a 1 point perspective drawing and take some of those horizontal lines that we drew and have those connect to another vanishing point, or even the vertical lines that we drew. So in a 1 point perspective, those are all parallel, but those will eventually connect to a vanishing point in a 3 point perspective drawing. If you look on my channel or the announcement on Canvas, I have a video explaining the differences between 1, 2, and 3 point perspectives that you can watch. But the expectation is that most of you will be able to make a nice 1 point perspective drawing, and that will include some nice details. All right, good luck, and start thinking about what type of object you are going to be drawing for this next project.